microservices with Kubernetes? Not bad. Who's doing microservices with Kubernetes and logging everything to an elk stack? Cool, so there are some people in this room who are like, all these talks, yeah, I'm done all this stuff, that's fine. For the rest of you, well, listen up. Okay, so next speaker. Was the picture any good? Too nice. Well, lots of people going over seconds there, so it must have can't be too bad. Okay, so second and a half speaker for the evening is Jakub from Skyscanner. I asked him if he'd come down from Edinburgh today, but he's actually based in London. But the rest of the team is up in Edinburgh. So Jakub's going to talk to us about how to be productive in microservices. The stage is all yours.
Thank you. So yes, I'm Jakub from Skyscanner, and I will tell you what we do at Skyscanner to make sure that our engineering team is able to ship features faster than everyone else. First, who knows Skyscanner? Perfect. It's always nice. For those who don't, Skyscanner is a search engine for flights. So you enter where you want to fly from and where you want to fly to, and we give you prices from all airlines and all travel agencies. So it's important to know that we are something similar to what Google is to the internet. So we don't sell you tickets, we just show you what options you have, and you then buy directly with the provider. Apart from that, we do a lot of stuff like we have Facebook Messenger bot and Alexa bot, and we also have a hotel search engine and flights for business and a lot of stuff. As a company, we are a Scottish company, founded in 2003. A huge growth started like 2010, maybe a little bit later. Now we are in 10 offices, more than 800 people, and a number which I find quite fascinating is that in 2015 there was 12 billion pounds worth of airline tickets bought through Skyscanner. From the technology point of view, every day there's 12 million searches for flights, which translates to 100 million requests for partner data and 5 billion prices displayed. In the background, we are integrated with 1,200 partners, which is quite a lot of integrations, and there is 65 million unique visitors every month. So if you take a look at this website, that's how it looks. Quite simple, but coming from those numbers which I mentioned, you can imagine there is a lot of complexity hidden behind it, and a lot of infrastructure and a lot of stuff happening, which means that it's challenging to make sure that we can improve and ship new features quick enough. And actually, let's take a look at how Skyscanner engineering looked in 2013. This graph shows it all. At the end of 2013, we've been able to ship once or twice every month. It took 21 days to test the product end to end. Every second release had to be re-released because of the defects in the product. And so on. So basically, we decided we need to change something, otherwise we will not be able to compete in this very competitive market. Also, of course, we were using data centers, so it took like 6 weeks to get a new hardware and so on. Okay, this happened to me before. This froze a bit, but it will wake up. Yes, so I want to speak about what we did since 2013 to improve the situation. In 2016, Skyscanner has a goal to become like, to be able to, or I don't remember the exact wording, but to be able to have like world-class engineering at scale. First goal is that we want to be able to do 10,000 deployments to production every single day, and that we should be able to take idea to production in an afternoon. So as you can see the difference between like 6 weeks to provision infrastructure and then idea to production in an afternoon, you see that we've made quite a lot of progress, and I will tell you what we did. And please remember, this is like a quite big organization, it's not a one-person startup, so you can do it easily if it's just you uploading stuff, but if the company is big, this is challenging. So let's go through the steps which we did and which we are still doing and see. Hopefully we'll be able to apply some of those yourselves. First step is actually not technical, it's organizational. We need to make sure, that was the first thing which we did. We needed to make sure that individuals and teams are actually empowered to do those changes which we want them to do. We define autonomous team as a team which defines their own backlog, which can ship to customer whenever they want, which can ship to customer without approvals, and which doesn't depend on anyone to make the change. We call those teams squads. It comes from Spotify, but it's not really important. The important thing is that teams need to be responsible for what they do, and they need to have the power to actually do the change. Second step. Originally, Skyscanner was a .NET-based solution, big monolith, big fat SQL server, and those kind of things, and this just didn't work anymore. So we embraced open source. It was quite a big cultural change, but it gave us a lot of options to use tools which are right for the job, like pick and choose solutions which did one job but did it well. That's just some of the technologies we use. And I believe we don't even use some of them, maybe ASP.NET MVC3, I hope we don't use it anymore. Also, when you do open source, you are much more attractive to potential employees, which is always useful. Step number 3, I hope that's not surprising, but cloud is really giving us power or like options to move fast. So, of course, previously 6 weeks to get new hardware, now a few minutes. A lot of services comes out of the box, like databases, load balancers, you know what AWS has. We decided to invest 100% in AWS, so we do not try to make our services like able to be run on premise and in Azure or Google Cloud. No, we just say let's go full AWS. That's what we do. Step number 4, Docker for everything. I think Docker is also now quite well adopted, or it's quite well known that Docker is a good thing to use to run your services. I, however, want to stress out that it's good to go further than that. So we use Docker for CI, for example. We use a tool called Drone.io, which is this logo, which has many advantages. I'm sure all of you remember like those struggles when your build agent support just one version of, I don't know, Node.js, then one team wants a newer version, but this breaks existing services. So you create another build agent, and then you have suddenly 100 of them, and it's just impossible to maintain. With Dockerized CI, a team who defines the CI process is able to choose what's the environment where the CI runs. That's extremely powerful. And second thing which I want to mention is Docker for development environment. So with those squads which I mentioned at the beginning and teams which are autonomous, there will be situations where one team needs other team to do something for them, but that's not a priority of the other team. So we need to make sure that internal open source model works well, and that one team can contribute to other teams' projects. And having this development enablement environment, Dockerized helps tremendously, because you can very easily run other teams' service locally without installing stuff and so on. Step number 5. This is my favorite, because that's what I work on. So we want to make sure that when you decide to take this new idea to a production in the afternoon, you don't spend time on those boring things and repetitive tasks which you usually do. And I mean, choosing web framework, choosing structure for the project, choosing third-party libraries which you will use, deciding how you will monitor your service, deciding how you will deploy your service, and I can go on. So our team, our squad, makes sure that all of those things are taken care of. So when you decide to start a new service, it's one line command for you. You enter a few choices, like what's your name and so on, and then you can immediately write business logic. That's very, very important. We use a cool tool called Cookie Cutter. To do it, we have like a template, and then this tool takes the template and generates the service. I want to stress out, like, production ready. I don't mean like service which does something useful, but it's production ready in terms of all those non-functional requirements which you need to do. So normally I've been at places where first you spend a month developing a service, a logic, and then you spend another few weeks making the service production ready. Here this is done for you in the first 5 minutes. And this is a screenshot showing how it looks. So Cookie Cutter is a command. It's an open source tool. It asks for few things, then it generates the service to the folder. You're able to push it to Git and write code. A thing which comes very, very close to the previous step is deployment. Deployment has to be something developer doesn't really think about. It needs to just work. It needs to be 0 clicks, as we like to call it. And in addition, it has to be safe. By safe, I mean that if it's something developer doesn't have to think about, developer has to have a confidence that it works, that it doesn't break any existing service when you deploy something. So we are utilizing blue-green deployment technique, which makes sure that metrics defined by developer don't go down with new release. So those metrics can be whatever developer wants. So typically, I don't know, like if service returns 500 error codes, that means something is wrong, and the deployment will not go live. I want to explain this picture. So blue, green. First, blue is live, then you deploy green. Both of them are deployed alongside load balancer, sends a bit of live traffic to the new version. Metrics are checked whether they still show the right signs, and then all traffic goes to B, and service A is taken down. With this, I want to also mention that we've moved away from manual testing. So previously, as I said, it took I don't know if I said it, but it took 21 days to test the service end-to-end, like manual work in 2013. Now we don't have any manual testing. So we rely completely on tools, of course automated tests, and those metric checks, which are very powerful because they are based on real traffic. And of course, I want to mention that we are in quite comfortable situation because we have huge traffic. So if we send just 3% of visitor to the new version, which might be broken, we still have a lot of traffic to evaluate if it works, but the impact isn't that big. And the last step, which is very important, maybe most, and also very difficult, is that teams, developers, have to be able to make data-driven decisions very easily. So again, to make data-driven decisions, you cannot be forced to spend significant amount of time into developing it, because if you are forced, developers won't do it. So to make this happen, we have an internal team taking care of the data platform which we run, which collects all the data emitted by all the services at Skyscanner, and then provides tools which are extremely easy to use to actually learn from the data. So this works well with the thing which I said, that you have production-ready service in 5 minutes. This includes metrics. So you have this service, but also you have a dashboard which you can use to see how this service is performing. So then it's up to you to just watch it. Also, of course, you can set alerts if something goes wrong and so on. Metrics is just one thing. Another thing is actually making business decisions. So if we go back to our goal from before, to be able to take an idea and put it to production in afternoon, sorry. Well, idea isn't useful if you don't know if it improves the situation or made it worse. So when we say to production, we actually mean to have an A/B test running in production, evaluating how this idea is performing. And this, again, A/B testing platform is a first-class service at Skyscanner and very easy to use. Basically, all new features are A/B tested by default. Data platform is actually our second largest service in terms of number of instances, and I think largest in terms of throughput. There is like 100K messages every second at peak. Very big thing, and there is, as I said, a dedicated team maintaining it. That was it. Let's go through the steps quickly, just to make sure that you remember. First, empower individuals and teams, squadifications, empowered teams, autonomous teams, and so on. Embrace open source, use what's out there. Embrace cloud, choose whichever cloud you want, but bet on it. Dockerize all the things, not just services. Make sure that your developers are able to create a new service in 5 minutes if you want to have microservices architecture. Make sure you can deploy with 0 clicks and to make it safe. And be able to make data-driven decisions very quickly. I'm quite happy to say that using those 7 steps, we've been able to achieve our second goal. We've been able to make sure that our engineers can take an idea to production in A/B test in 1 afternoon. At least for some services, of course, for the new ones, you cannot move everything from data center to cloud in 2 years in such a big solution. But all I want to say is that it works. At the end, I put down 3 things which are also quite good to remember and keep in mind when deciding which path you want to take. So first of all, we have found out that speed of iteration beats quality of iteration, or maybe it wasn't really us who found out. That's a law from 1950, which someone smart came up with, but it's proving to be true at Skyscanner. it's better to be able to iterate quickly than to first focus on quality, because if you iterate quickly, the quality will come. You will just iterate there. It's necessary to invest in enablement functions. So those things like having a forkless deployment, having data platform, being able to have a production-ready service running locally in 5 minutes, someone needs to create all of this. So you need to make sure that you have people dedicated to working on features which make other developers quicker. So those people don't like produce customer-facing products, but they do make sure that other developers are able to produce them quicker. By the way, at Skyscanner we have like 40 engineers in development enablement. That's what we call those people who develop internal tools, and another like 20 or 30 in data. And also, you need to be aware that benefits won't be immediate. At first, you need to go a bit slower than you are used to in order to be able to go faster in long term. Thank you.
Stuff, great talk, thank you, Jakub. Does anybody have a question? Yes. Marcus, you've moved over there.
Very good talk. Can you comment a little bit about the journey, how you grew a team that was supporting these values, and how you pushed for them, and that you keep innovating in that way? Because what I find is you will find a few engineers who want it, but like then they cannot fight the management. So maybe you have a very flat structure in Skyscanner, or essentially who drew the change and who maintains it at this level.
Mm-hmm. Yeah, that's a good question. We have a flat structure now, but didn't necessarily have it before. And what helped really a lot, that it was actually management who drove those changes. We are very lucky that we are still a private company. For like majority of the company is still private. We don't have any like big pressure on being like getting revenue in the short term. So our owner is still like thinking in the long term. So it was actually management who came up with the idea and motivated other developers, and this helped a lot.
Cool, so question over here somewhere. Yes. Rory.
So you're trying to get to 10,000 deployments per day?
Mm-hmm.
Per day, yeah. So my question is, how many people, how many teams, how many different units of the various sizes you have that would make it a requirement to get to 10,000 deployments per day? The other thing I see you're using Elasticsearch or Solar, some of those technologies. If that is the back end for the flight data, would Skyscanner consider like making the search more flexible, because that's a big team using Skyscanner?
Yeah. So first, around about 10,000 deployments. Yeah. So we actually don't want to do 10,000 deployments every day, because that's just not what we need to do. We are like now 500 engineers. We don't need to do 10,000 deployments, but we want to be able to do. So we want to have infrastructure which is capable of it, to make sure that when it can handle whatever we throw at it. And second question, so we use Elasticsearch not to store the actual routing, like prices and stuff. It's for analyzing data, analyzing metrics, making business decisions, and so on. And I would like also to stress out that it's quite a difficult problem, because the flight prices change very often, and you cannot just query an airline and tell them, give me all of your flight prices for the next month. They won't give you that information. So there is quite a lot of tricks with caches and querying just for one day, but trying to be smart, trying to predict, and so on. Yeah.
Great. Any other questions for Jakub? Yes, one in the middle there.
So do you do continuous integration production environment? Blue green and 10,000 deployments a day?
Oh yes, definitely. So new services are deployed to production on every push to master. If that's what you mean, like, and by deployment I mean that the whole, of course, pipeline is done. So from tests, integration tests, like creating Docker image and then publishing, and then, well, yeah, go on.
So if you aim for 10,000 deployments, like 1 every 8.5 seconds of production, how many is that in the test environment? Is it 20, 30,000 deployments a day?
So again, it's not something we want to actually do, to do 10,000 deployments per day, but to be able to do it. And I guess, yeah, if we want to be able to do 10,000 deployments to production per day, we should be able to do much more to, like, not production as well. Yeah, it makes sense.
Cool. Anybody else got a question? One more? Marcus, you've held one already. Anybody else? Anyone whose name I don't know? One question. Actually, I don't know your name. Oh, go on then. Marcus, last one. Just want to see me run, don't you? Someone on the back. There's a question over there. Sorry, dude. Ask him later.
Hi, a great talk. This question might not be very relevant technically, but I always had a suspicion that search engines and airlines hiked up the price based on your IP address. Is that true?
Yeah, to answer that.
I would like to actually. It's not the first time I hear it, not the last time. Some of them do, but we don't. We don't, never do it. So. But I want to say, yeah, we recently recognized that a lot of people basically have things about this, and there is like some cheat sheets online, like how to use Skyscanner, yes, so use private browsing, clear your cookies, and go to your Wi-Fi, to your mobile network, and so on. So we are thinking about how to communicate better that we really don't do it. And second thing is, what the prices we show is the price which airline will offer you. So we don't have commission over the price. We take a small commission, but it's how to say it, like, you pay to the airline and airline pays us. It's not over the original price.
Great, so some tricky questions there, not only on the technology, but you weren't expecting that. So. Jakub, thank you very much.
Thank you.